Hello everyone, welcome back to my channel Saisha's Tech. This is Amok Kaliva. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about logistic regression. What is the concept of logit or sigmoid function? Thereafter, how to build hypothesis in logistic regression. Optimize this built hypothesis using cost function and gradient descent. Thereafter, building the decision boundary with an example for logistic regression. And lastly, we concluded the video with some of the tips for data pre-processing of logistic regression model. In today's video, we will be understanding about multi-class classification of logistic regression. In the last video, we only explored about binary classification of logistic regression model. Thereafter, we will also understand the concepts of odds ratio. What is odds ratio? Mathematical formula application of odds ratio in logistic regression. Till now, we were understanding the logistic regression as a binary classification. But in practical examples, we might have multi-class target variable. To solve that problem, let us understand how we can do that using logistic regression. For classifying the multi-class logistic regression target attribute, we work on a concept of one versus all. Now, what is one versus all? If we have a three-class target variable, triangle, circle and square as our levels in the target attribute, then we create three hypotheses in which we consider one of the level of target attribute, example triangle as the positive case, the rest two circle and square as the negative cases. Similarly, we will also build for square as a positive case and the rest two as negative cases. Then circle as a positive case and the rest two as negative cases. In this way, we build three logistic regression models. Now, when we have an unknown data or the test data which is forwarded to us, we predict it with all the three models. In this way, we will know the probability. Consider, if with the hypothesis 1, we are getting a probability of 0.2, with the hypothesis 2, if we are getting a probability of 0.8, and with hypothesis 3, we are getting a probability of 0.5. Then we can understand the new data which we have received is having a target attribute as square. Why? Because the probability of hypothesis 2 output is greater than the other two hypothesis output. This is how a multi-class classification of logistic regression concept work. Now let us understand the odds ratio. Odds ratio is used to describe the winning chances. If we have the probability of success and we can calculate the probability of failure, the ratio of these two, the probability of success to the probability of failure, is known as the odds ratio. Mathematically, if P is represented as the probability of success, then 1 minus P is the probability of failure. The ratio of P by 1 minus P is the formalized way of representing odds ratio. Let us understand with an example. If you have a team which has the winning probability as 0.8, that is, the probability of success is 0.8. What would be the probability of failure? Which is equal to 1 minus 0.8. Then the ratio would be 0.8 divided by 0.2. 4:1. Here 4:1 is the odds ratio for the winning team. This is how a concept of odds ratio is represented as. Now let us understand the odds ratio scenarios mathematically in logistic regression. Let us understand the concepts of odds and logistic regression. The probability of success is represented as P of I, and the hypothesis of any of the model provides us the probability of success. In case of logistic regression, the hypothesis is represented as 1 over 1 plus e raised to minus theta 0 plus theta 1 x, where theta 0 and theta 1 are the parameters of the hypothesis. If we interchange the denominators and numerator on the either sides of the equal to sign, it gets represented as 1 plus e raised to minus theta 0 plus theta 1 x is equal to 1 by p1. Taking the 1 to the other side of the equal to sign, we get p of I divided by 1 minus p of I. Taking the logarithmic on both the sides of the equal to sign, we get log of p of I divided by 1 minus p of I. You can observe that p of I divided by 1 minus p of I is the odds ratio. That is the probability of success to the probability of failure. Now you can observe that the logarithmic of the odds ratio has a linear relationship with the input parameters. If we transfer the logarithmic value to the other side of the equal to sign, the odds ratio for logistic regression is represented as e raised to theta 0 into e raised to theta 1 x, which means if there is a unit change in the input variable with an exponent of the input variable, there is an effect on your odds ratio. These were some of the concepts of odds ratio and logistic regression. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.